You have to apply the margin of error to an average. Jump in here and help her. Speaking of average, time out. What is the average of our data?
3.5 or something.
We get a 3.5?
Yeah.
Get your homework stats. We got 3.5. Good, good. Let's put that over there. Actually, I'm going to come back to your question, Carol. It was an awesome question. Thank you. Let's come back to that. So you guys ran the data on this. Now, hopefully, you can see that it's got to be about 3.5 by that histogram. Yes. This, FYI, keep this in the back of your mind. This is called a uniform distribution. When basically everything is the mode, that's called uniform, because everything is equally likely. So it's uniformly the same results for each one. A coin flip is a uniform distribution. Rolling a single die is a uniform distribution. Pulling a card out of a deck and looking at its suit is a uniform distribution. Because every outcome is just as likely as every other possible outcome. Fair? When you start changing it is when you start mixing other dice and cards into the mix. But right now, this is called a uniform. So if this was a plate of cookies and you're the waiter trying to carry it, thereby finding the average, you'd have to have it right there, correct? You'd have to have it right there in the middle to find that average. Now, of course, you don't have to believe me. You can also run the average on L1 and L2, but there she is. You got about rounds to 3.55 in our case, but 3.5 it rounds to. And you got a little beautiful little standard deviation. So for our roll a die experiment, we come up with an average of about 3.5 and a standard deviation of about 1.7, which is roughly half the average, which is kind of fun. Kind of funny. Fair enough so far. 282. There's our sample size. Quite nice, my friends. Quite nice. Okay. So one way to figure out the average of a die roll, or the average of anything for that matter, is to collect data like we just did, create a distribution like we just did, and then run it. Okay. But I think we could have done even better. I think we could have done even better from the beginning. And why do I think that? You knew something about those dice as soon as I handed it, or that die as soon as I handed it to you, right?
A 1 in 6 chance of getting.
You have a 1 in 6 chance of getting a 1.
Yeah, or a 2.
Or a 2, uniform, all the same, right? What does that mean? You have a 1 in 6 chance. What does that mean? You have a 1 in 6.
If you roll a die 6 times, probability one of the times you're gonna get it.
I love that, Lauren. May I test that if that's okay?
Sure.
Okay. Did you hear what Lauren just said?